Alright, so I'm going to go ahead and do the quadratic application problems, guys. So let's look at number 36. This one says a rock is thrown from top of a building. The distance in feet between the rock and the ground t seconds after it's thrown is given by d equals negative 16t squared minus 4t plus 382. How long, so they're looking for time right here, how long after the rock is thrown is this 370 feet from the ground? So 370 feet is the distance. So I'm going to plug 370 for my distance. So 370 equals negative 16t squared minus 4t plus 382. Now I'm going to go ahead and grab my handy dandy calculator, and I'm going to plug that straight into my calculator. So in y1, I'm going to plug in my formula, negative 16. Instead of t, I'm going to write x minus 4x plus 382. And then for y2, I'm going to go ahead and plug in 370. Now this is a really big number, so when I graph it, you probably won't be able to see it very nicely. Nope. So I need to change my window. I'm going to go to Zoom Fit, hit the zoom button, and then go to Zoom Fit and see if that gets me a better picture. There we go. So now I'm going to zoom out just a little bit. You can see how we're very close. So I'm going to zoom out just a little bit. There we go. There you go. Now you got a really nice picture of our quadratic function. So we're here. Now I want to figure out, so this line right here is y equals 370. Let me go ahead and figure out these intersection points. So I'm going to do second trace, intersect. First curve is my parabola, enter. Second curve is the line, enter. And then I'm going to guess over here. So that's negative 1, 370. And let me go ahead and do the same thing again. Second trace, intersect. It says first curve, make sure it's on the parabola. It does not matter where. Second curve, it just has to be somewhere on the line, enter. And then I'm going to move it over all the way here. So this is going to be 0.75, 370. Now the question says, how long after the rock is thrown is it 370 feet from the ground? So remember, the rock is thrown from the top of a building. So it doesn't, you don't throw it up and then down, like you're already at your maximum point. So we really don't need this left side of the graph. It's here, the maximum point, and then you drop the rock. So I want to know how long after the rock is thrown is it at 370 feet from the ground. So when does the rock hit 370? What is this intersection point? Your x value is your answer. So your answer is going to be 0.75 seconds. Alright, so I'm going to go ahead and skip to number 39 because that one's a little bit funky. Here, number 39 says, given the formula b equals L over 4 pi d squared, they want to know what is the distance. Solve for distance. So for this one, guys, you just have all variables, no numbers, and this is very common in math, in upper level math. You're going to see this in physics a lot. So they want you to get d by itself. It's kind of tricky. So I want you to remember from Algebra 1, when you had something like 5/2 equals x over 3. You guys remember you had two fractions and you had an equal sign. How did you solve this? You would have cross multiplied. And that's what gets rid of the fraction. So I'm going to do that here. I'm going to write b as b over 1 because I can. Because b over 1 is the same thing as b. I'm going to cross multiply. I'm going to say this times this equals that times that. So 4 pi b d squared equals L times 1, which is L. Which makes it really, really pretty, and now I don't have to worry about the fraction. Now I'm still looking for the distance. That's the variable d. So if you guys see here, these are all being multiplied by each other. So in order to get d by itself, or at least d squared by itself, I'm going to divide by 4 pi b. And what I do to one side, I do the other, 4 pi b. So the 4's cancel, the pi's cancel, and the b's cancel. So then I get d squared equals L over 4 pi b. And so in order to get d by itself, I'm just going to take the square root. And distance is always positive, so it's going to be the square root of L over 4 pi b. And since they don't give me any units, I'm going to write just units on the outside. That's it.